Hello and welcome to this training on electric vehicle and hybrid high voltage safety. In this training, we're going to go through and do a few things. We're going to identify some high voltage components, understand the dangers of high voltage, demonstrate when we need to use PPE, personal protection equipment, and perform some high voltage depowering on some of our common vehicles that we have here at the school. So why concern yourself with high voltage safety training? Well, it's because there's a lot of hybrids and electric vehicles that are coming out in the market now. And in this program right here at SIU, it might be your junior or senior year before you take the hybrid or EV course. And there are plenty of courses that you could potentially see a hybrid or an electric vehicle in that may or may not have to do with high voltage. You could have a lot of things that are going to be working on brakes, steering, suspension, or body electrical. Those are areas that typically you don't have to worry about high voltage. But if you're concerned about it, we'll go through and take this high voltage training to kind of let you know when you need to be concerned about high voltage, the dangers involved with working around high voltage, and how to protect yourself properly. So you might have heard the adage, it's not the voltage that kills you, it's the current. And there's a lot of truth to that. So why concern ourselves with high voltage training? It's because traditionally your 12-volt vehicle that we've got doesn't have a high enough voltage to pass any decent amount of current through your body to cause any of these issues. But now we introduce vehicles like a Lucid that has a 900-volt battery, or a Rivian that has an 800-volt battery, or most of your conventional 400-volt systems like the Nissan Leaf or a Tesla Model Y. Those have a high enough level of voltage that if you got into the wrong spot, you could now pass a decent amount of current through your body to cause these issues. Here you can see at 2 milliamps, that's the first level. That's where you feel a shock, so that's mild pain. At 20 milliamps, 1/50th of an amp, that's not much, will cause a muscle contraction. The reason why that's a big deal is if you're becoming electrocuted with 20 milliamps current flowing through you, you might not be able to let go because your muscle is going to contract on whatever that device is that's electrocuting you. And at 30 milliamps, you could suffocate because that diaphragm's a muscle and it's moving your lungs. And if it's contracting and not allowing you to breathe, you're going to suffocate. At 100 milliamps, your heart could stop beating. It could just knock your heart out. That's not good. And then if you're passing quite a bit of current flow through, you're going to get extreme and severe burns. So you want to avoid, obviously, all of this, and we're going to do that by being safe with high voltage. So you might have heard all that and said, I'm not going to mess around with these hybrid or electric vehicles. They sound way too dangerous. I don't know if I'm going to get into something I shouldn't. Well, don't let that scare you. The majority of these vehicles you're going to approach them just like you would a traditional internal combustion engine vehicle that is not high voltage. A lot of the parts of the vehicle are going to be the same. All the interior stuff is still going to operate off of 12 volts. Our lighting is going to be 12 volts. Our undercar, the suspension, the brake system, that's all the same. And you don't have to take any special precautions other than what you would normally do, and you would refer to service information for that. The way that we identify high voltage is we look for the orange cabling. And if you ever suspect that maybe you shouldn't be getting into these parts, go to the service information because it will identify whether or not you have to disable the high voltage system in order to work on it. Things that would require high voltage service considerations are going to be any high voltage component, like if you're going to pull the high voltage battery out, or the inverter out, or the converter, the DC to DC converter. It's the component that takes the 400 volt battery and generates 12 to 14 volts out of it. If you've got electric vehicle supply equipment, EVSE, that's the charger, you will want to take that into consideration. If you're going to pull the transmission out, if you're going to do air conditioning work, now this is something that's kind of conventional work, air conditioning work, and that is something you have to take precautions for because on most hybrid and electric vehicles, they've got electric air conditioning pumps. They're not belt driven. And if you've got an electric vehicle, it's likely got a PTC heater. It's like an electric element heater, or it's using the high voltage electric AC pump to create heat. So either way, these are operating off high voltage, so if you have to work on those, you will definitely have high voltage considerations to take into place. And if you're doing any major component overhaul, if you're pulling an engine out or a transmission, you're pulling some of these high voltage components out like electric motors and so forth, you'll definitely want to do high voltage service considerations. So in this little video I've got here, I just kind of scanned the underhood area of some of our common hybrid and electric vehicles that we have here at the program, and really just to identify any of the orange cabling that you see. This first one that we're looking at here is the 2018 RAV4 hybrid. And you can see I'm going to pan down and that right there is the AC compressor. That's the high voltage going into it. Then it kind of wraps around and comes back into this converter assembly. These three plugs right there power up the electric motors. That's the rear, and those other two go to the front motor transmission. This is the Nissan Leaf, and you can see a bunch of cabling. Up towards the front is where the charger, that's where you, under that fender cover is where the charger plugs in. And you can see that is the air conditioning compressor on it. So they mount it between the kind of the wheel and the electric motor assembly. There's a little warning tag on there to kind of remind people that it's high voltage. This is the Toyota Prius. If you look, you don't hardly see any orange cabling here. If you kind of, they got an air conditioning compressor way down there too. The cable kind of comes in from a weird spot, and then it kind of comes around and goes into their converter assembly right there. You can see a little bit of orange in the back, but they hide it really well on that. This 2015 Chevy Volt, they've got all kinds of cables. You know, these are powering up the two electric motors that are in a transaxle. This is the power coming in from the battery. And then that goes over to their air conditioning compressor, where you can see it goes right down, pretty much in the same spot that the Toyota was found in. They actually have a charge controller behind the headlight and goes all the way around to the outside where you plug your charger in. So kind of a roundabout way to get the charge cord plugged in. On this Lexus, very similar to the RAV4, you've got our three motor connections right there. There's the rear, and then there's the two front motors. And then coming right around, just like on that RAV4, we've got our connection for our air conditioning pump. All these orange cables, those do a pretty good job of identifying all the high voltage components that we've got. This is the Subaru Crosstrek, and they put, on their hybrid, they put it all in the back. So they have the electric motors kind of combined with their transmission in the back, but they've got the high voltage battery right there, and then some of the electronics here, and everything, there's a service plug. Everything that you see in the very back is related to their hybrid system. In this Ford Fusion, you can see the big cable with the battery power coming in. And there's their air conditioning compressor, just like the Volt, just like the Toyota and the Lexus. And we can see some big motor battery connections on the side there. You know, it's pretty obvious to see the high voltage componentry by looking at the orange cabling that we have. So that gives you an idea of, when you're working on these things, what has high voltage and what doesn't. So as far as precautions, one of the first things you're going to want to do is look at service information. No matter what you're working on, look at the service information, see if it has you deal with the high voltage system at all. So if the service information has you handle high voltage, they're going to direct you to making sure you wear your PPE, and gloves are the big thing. This is what's going to protect you from high voltage if you come into contact with it. These gloves have a red label on here, say they're class 0. That's going to indicate that they're good for 1,000 volts. And so you want to see that red label, and it's got to be class 0. Also, there's going to be a certification date. This one says July 19th, 2024. That's when this was certified. So I have 6 months from the date of certification, if this was recertified, to use these gloves. After 6 months, I need to go through and certify them again, even if I haven't used them. So now a new pair of gloves that's still in the original package, it hasn't been opened up, you actually have 12 months before you have to get it recertified. And after 12 months, you're still going to have to send them back to get recertified, even if they've never been put into service. The rule states that at any given point, that a new pair of gloves within the previous 12 months would have had to have gone through certification. Now the 6-month rule still applies, so if you open this package, for example, at month 3, at month 9, you're going to have to get this certified. Or if you open this package at month 6, you can get it certified after the full year, after 12 months. If you open this package up at month 8, you only have 4 months of usage before you have to get it certified. And as I said, if you never opened up the package and it's over a year since the date, you're going to have to send it back and get recertified, even if it's never been put into service. So after this gets recertified and comes back, I've got 6 months. I don't get to apply the 12-month timeline or anything like that because it's sitting in a package. That package timeline only counts if it's brand new. So no matter what, if I recertify and get it back, even if it comes in a package, it's only good for 6 months at that point, and it needs to be recertified again. So even if this glove is certified, I want to check it before every use. I'm going to pinch the ends together like this and roll it up on my chest. And you can see that traps air in it. And that should stay inflated. If it's deflating, I'm going to listen and see if I can tell where the air's coming out. There might be a pinhole leak somewhere. If that's the case, this glove would fail a test, and you cannot use a glove, and you can't repair it either. So it's just a bad glove at that point. So if this glove holds air pressure like it's supposed to, then I'm going to want to go through and ensure that there's no blemishes on it. If that looks good, then I can go and use my leather outer gloves to protect it. The reason why I use leather outer gloves is because the rubber can get damaged easy. It can get dirty, get solvent, whatever, oils on there. The leather protects the rubber gloves. The rubber gloves protect you from electrical current. So the leather gloves themselves are not there for protecting you from shock. They're there just to protect the gloves. When you're sizing the gloves, if you're buying gloves for the first time, you measure your hand around your knuckles. And whatever that is in inches, that's the size glove you need. So if that came out to be 9 inches, then you want to get a size 9 glove, and then you get one size above that for the leather. So I ought to have a 9 glove and a 10 outer. And when you store these gloves, you don't want to crumple them up. You don't want to do that and shove it into the little storage bag. Keep them straight, slide them into their pouch, and that way they aren't stressed out or stretched in any fashion. Aside from the gloves, you also have other things like shoes. You got to wear rubber-soled shoes, even though pretty much all shoes are probably rubber-soled. Maybe cowboy, don't wear cowboy boots. That might be the point of that. Safety glasses, wear those safety glasses. If you've ever seen a spark from arc, now hopefully you'll never see that on high voltage, but if you ever do see one, the little spark, that's molten metal flying away. So you definitely wouldn't want that in your eyes. And then the meters and leads. So these meters that you're using when you're checking high voltage stuff, they need to be Cat 3 1000 volt certified. And look for that label to make sure it's actually a Cat 3 1000 volt. If it's not, then it's not designed to handle the voltages. It's not certified to handle the voltages that these EVs or these hybrids could contain. You also want to make sure any probes, alligator clips, or anything that you attach to your meter leads, those are also Cat 3 certified, Cat 3 1000 volt certified. So the next step in the service information is likely going to have you depower the high voltage system, either using a high voltage service plug disconnect or a low voltage service disconnect, and then possibly even have you go through and verify that there's no voltage left on the system. And because you're not likely the only person working in the shop, the service information is going to have you go through and identify the vehicle as being worked on, maybe even lock out or tag out the high voltage disconnect or the low voltage disconnect to prevent anybody from inadvertently going through and re-enabling the high voltage system and then you coming back to work on it when the vehicle could then be compromised and dangerous. Now, another precaution is towing or pushing a hybrid or electric vehicle around, and that's because many of them use permanent magnet electric motors. And if you rotate a permanent magnet in an electric motor, it's going to actually create electricity. And the electricity, the voltage that it creates might, depending on the failure of the vehicle, it might be finding its way to a place it's not supposed to go. So your best bet is to, if the vehicle has tow mode, is to enter it into a tow mode. Second best bet, if it doesn't have that, is make sure you're on dollies or make sure you're on a flatbed when you're towing that thing around. Even in the school, if you're moving a vehicle around, if it's got a failure and we can't put it into a tow mode, you can put it on go jacks and you can move it around. That ensures that the wheels aren't spinning and these electric motors aren't creating voltage that could be damaging components, especially if you've got a failure within that vehicle. So another service precaution that you might not even think of is lift points. Read the service information to find out how they want you to lift the vehicle. If you've got an electric vehicle that has a battery, those batteries are very heavy. They might have special adapters that go along with the body to support the body properly so that way when you drop the battery out, the weight is properly arranged and the body stays stiff. Some battery packs have the structure to the body built into the battery pack. And when you remove that battery pack, the vehicle becomes a little more flimsy. So they might actually have special adapters to accommodate that. This first vehicle we're going to look at is a 2018 Toyota Prius. And Christy's looking up the service information right now. And you can see it there listed right in all that as high voltage system disable/enable. and there's also technician precautions. On the technician precautions page, it's kind of general, and when you scroll down, it has a little bit of everything, but when you scroll down, it has you check the PPE to make sure there's no pinhole leaks. It also gives you a little bit of information on how to do the lockout, tag out information. Now when going through the specific information, you can see after unplugging the service plug, wait 10 minutes, and that's to allow capacitors to drop. And they want you to check the voltage at these terminals on the inverter to ensure that there's no voltage. You're doing all this with your PPE on, and you should have 0 volts after 10 minutes. Here, Christy's checking the glove, inspecting it to see if there's any damage to it, giving you the thumbs up, saying it's in good shape. Then she's going to slide the leathers on over that. Good shape on those. Now we're going to go to the service plug. It's behind the rear passenger seat. You can see there's an access cover there. And you pull the lever down, then you pull the lever out, and then you pull the plug. And you store the plug in your pocket, and you wait 10 minutes before you do any work on the vehicle. That's to allow the capacitors to discharge. Now these are low voltage connections. You can see she's got her gloves off because there's no high voltage at present anywhere at this point. And this is just to get access to that cover that she needs to remove. And now you see she's got her gloves back on again. So she's going to take that one 10 millimeter bolt out. Once that 10 millimeter bolt is out, she can pull that plate out of the way. That plate basically just covers 2 spots that you can stick a meter and check to see if there's any voltage. And this is a live, dead, live test. So she's checking the battery first. Ignore the fact that the battery's not very good. It's a school car. And then she's got her meter leads in the checkpoint, and it shows 0 volts. And that's good. That means the capacitors did discharge. Making sure the meter's not just stuck on 0, you do the live test again. So live meaning you check a live circuit. Dead, you ensure the high voltage system is dead, and then you do live again to make sure that your meter is reading properly. And here, according to the service info, they want you to go ahead and pull the negative post of the battery or the negative connection of the battery off. You're actually supposed to tape that to prevent it from kind of drifting into contact. Then when you're done, you put your gloves back in, you store them. You don't crinkle them up, you put them in there flat, and you store everything in their little bin. So as a review, she reviewed the service info and tested her PPE. She removed the high voltage service plug, waited 10 minutes for the capacitors to discharge. She performed a live, dead, live test at the inverter to check to see if there's any high voltage still present. And then once it passed that, she was able to disconnect the negative battery cable. Next, we have Christy going through the 2024 Nissan Leaf and depowering it. It's a little bit different. And she knows that because she went to All Data and went to the high voltage system, disable, enable. And in there, you can, while reading, she could see that you start by disconnecting the negative battery cable, and then you go to the back seat of the vehicle and remove the cup holder and little cover, pull the service plug out, make sure you're wearing your gloves, and then they want to make sure that there's no voltage present on the system. And there's also a section for precautions, and in there, once again, it gives you warnings, and also talks about if you have any implanted medical devices, like a pacemaker, that you probably don't want to be working on the vehicle. So they also want you to print off a little sheet basically saying, hey, there's somebody working on this, don't touch it. She's protecting the vehicle's finish by putting a Bosch fender cover on. And removing the negative post of the battery cable. Now she's checking her PPE. She spun up her glove there, trapped some air in it, and she's looking and listening for leaks. No leaks are found. After sliding the glove on, she can take a look, make sure there's no damage to the glove, And then she could put the rubber outer gloves on and make sure there's no damage to those. So after pulling the cup holder out, she's pulling the 310mm bolts that fasten the steel plate on. Now you can see she lifts up on that connector, then she pushes in on that tab right there, and then lifts it up the rest of the way, and then reaches in there and pulls the plug out. And there you have it. High voltage service plug removed. Store that in your pocket and wait 10 minutes. In this time, you can get the vehicle up in the air, maybe pull some of the covers down. Then after 10 minutes, you can continue on. And here she's pulling the bracket off that supports the high voltage battery cable. And now she's going to be removing the PTC heater connection. So this is a high voltage heater connection. There's a little tab on the side. That's what she used her pocket screwdriver to help with. Here, there's a little tab that she's got to push in there. She can push on that little tab. So there's like a few things that need to happen there. And then you can pull that battery connection back. Now we're going to do a live dead live. And that's, instead of using the 12-volt battery, this is actually what's called a proving meter right there. And it has 250 volts on it, thereabouts. So you push down on it, and you can see she's got 245 volts. So that proves that that meter can read high voltage. Then she goes over to the PTC heater. And she's ensuring that it's got 0. And it does. That means any capacitors, any stored energy that's in that circuit is depleted. And she goes back to double check her meter was not stuck on 0, and it wasn't because it's reading 245 volts. So that was live, dead, live. And she did the exact same thing with the inverter side of the battery connection, and then verified that the meter can still read 245 volts. A live, dead, live test on the inverter. That ensured that the capacitors were all discharged. And this step right here, she's going through, and preferably this would be done in orange tape, but she's taping off the battery connections so somebody can't go in there and just start poking things and doing what they shouldn't. So to enable the high voltage, you just basically do the same process in reverse. Push everything together, seat all the connectors, push the blue tab in there to basically lock that connector back where it's supposed to be. Lastly, she fastened the high voltage battery bracket in place, lowering the vehicle down. Installing the service plug, installing the plate cover, and lastly, tightening up the negative post of the battery. So in summary, read the service procedure. Disconnect the 12-volt battery negative cable. Disconnect the high voltage battery service plug. Wait 10 minutes to allow the capacitors to discharge. Disconnect the PTC heater and the high voltage battery connections. Perform your live, dead, live testing on the PTC heater and battery. If everything's good, tape the battery and the cable connections, and then reverse all that when you go to repower. So next we're going to go through the 2023 Ford Mach-E depowering example. And here we're using Ford's information because they didn't have it in all data yet. And when you read through it, they're going to say, you can use the manual depower or you can use the Ford specific. We're actually going to use the Ford specific because we have the Ford tool. And if connected, make sure you unplug the charger. That's what the EVSE is. Then also look to see if you have these DTCs. These are critical DTCs that indicate there's a problem with the battery pack, and they want you to be aware of that if you're going to be depowering and removing some of these high voltage stuff. So using the FDRS, they're going to go through and say, first, make sure the EVSE is unplugged, the electric vehicle supply equipment. We're going to protect this pretty finish that we've got on our Mach-E with our Bosch Invented for Life fender cover. You can see Christy's got the interface device, that Ford interface device over there. We're hooked up to the Ford FDRS. First, she's going to go through and do a self-test. Now she selects the battery energy control module, clicks the box to get the menu to drop down, switches over to just CM DTC, the continuous memory DTCs. And it's going to check for those critical codes. It's going to check to see if we've got any concerns that we need to worry about. And the only code that we have in here is a network code. It's a control module improper wake-up performance. No biggie. So she's going to close out of that, and then she's going to scroll down, and she's going to try to find, under the battery energy control module listing, the high voltage system depowering, and run that process. And it's going to walk you through it. That's the beauty of this tool, is it walks you through this whole setup. You're going to get communication to the battery energy control module. It wants you to switch to accessory mode. It's warning you that this has got 450 volts DTC, and just be careful. Okay, the first thing it's going to do is it's going to check the insulation resistance. That's the resistance between the battery and ground. And you can see that was in green, and that's good. And now it's going through and checking all the voltages on all these high voltage components. And of course, they're going to have voltage at this point because we haven't started the depower process. Now they want you to go through and follow the service info as listed in the service manual. And the pictures are on the left side of the screen, and she's first removing that center cowl piece, getting it out of the way, and then removing the left side cowl piece, getting it out of the way. Now you're going to notice she never has to use high voltage gloves in this whole process because this uses this low voltage disconnect right there. Now underneath here, there's not that many orange cabling. This actually doesn't have front drive, so there's no front inverter or front motor. So you can see she lifts up that lock tab and then disconnects the connector. It doesn't come apart, it just lifts out of connection. Now she's going to use a zip tie and go through the hole there, and that prevents that connector from ever reconnecting. And then you label what's the work that's being done. In this case, she's doing the high voltage battery. It's noon, and she's putting her name on it, so that way, if anybody wants to know what's going on, they can come find her. Then the machine counts down for 5 minutes. And that's the amount of time it would take to ensure that all the capacitors have discharged. Now they say switch the ignition position to accessory mode. So you just push the start button. This can ensure that all of our voltages are down low. As long as these voltages are low and they're green, then we know we're good. If there was a problem, it would be red. Now they want you to turn the ignition switch off. The high voltage system is de-energized. Remove the key from the vehicle. And then ta-da, application finished. Please press OK to continue. So as a summary, you disconnect the charger if it's plugged in, use the FDRS guided process, assuming you have the Ford tool, record any critical DTCs, monitor the system voltages pre-disconnection, it'll be red if it's bad, green if it's good, disconnect the low voltage connector and tag it, wait the timer in FDRS, which is 5 minutes, and then monitor the system voltages post-disconnection, should be green. If any of them are red, then there's still a problem going on, and then the depower is completed. So that was using the FDRS and the Ford specific scan tool. If you pick manual depower for this Mach-E, it would have you pretty much do the exact same thing, except all the steps that were guided with the FDRS, they'd be in the service information, and you wouldn't have that nice feature of it showing the voltages and the insulation resistance and all that. But still, it'd have you go through and depower the system in the exact same way using that low voltage disconnect. So let's say you can't find any service information and you have to disable this high voltage system. You could follow this generic process. Now you definitely want to follow the factory service information if it's available, but if you don't, this will make the vehicle safe. You could turn the ignition off, shut it down, remove the keys from the vehicle, lock them away so that way it doesn't try to wake up, disconnect the 12-volt battery, disconnect the negative cable off the 12-volt battery, and then find the service plug. It could be a high voltage plug or a low voltage plug, but find a service plug and remove it. If you can't find a high voltage service plug, there's usually a low voltage service plug found somewhere. It's sometimes called a fireman's loop. It's a low voltage interlock disconnect. And then you want to wait some time. 10 minutes would be safe, and that gives you the time for the capacitors to all discharge in the inverter, converter assemblies, and so forth. And then if you have the ability either to the battery, a PTC heater, all these different high voltage components, disconnect them with your PPE on and check for voltage. There shouldn't be any voltage at any of those components. Tape them off and then you should be good. Now you'd much rather use the service information, like for example, disconnecting this 12-volt battery. That's something that the Mach-E didn't even do. And you could have checked because they don't disconnect the 12-volt battery, you can use the scan tool to check for the actual voltage available at the different components. So that saves time by following the service information. You don't even have to use PPE to do the Ford. There's no high voltage. You don't even get close to the high voltage during the whole process. That's a better way to do it. Now that concludes the high voltage safety training, and hopefully now you can identify some of these high voltage components. You understand the dangers that surround high voltage. You understand a little bit about the PPE and how to test and use gloves and the meters and so forth. And lastly, you've seen a few depowering processes and you understand the process that it requires to disable the high voltage system so you can safely work on high voltage components.